Hello, in this video I'm going to show you how to calculate partial fractions with distinct factors. Now all this means, it sounds a bit weird, but it just means that on the denominator of your fraction, the terms you've got multiplied together are all unique. So for example, you could have 2x over 3x plus 1 multiplied by 2x plus 4. They're different things. You don't have the same thing repeated on the denominator. If you had something like 3x over 2x plus 1 all squared, you'll have to use a slightly different process, and I'll cover that in my next video. Another thing I don't mention in this, but it's quite important to know, is that to calculate partial fractions, the degree of your numerator has to be less than the degree of the denominator. So if you had a cubic on the numerator and a quadratic on the denominator, you couldn't use partial fractions, you'd have to use division first. But in all the examples you'll see, and all the ones in this video, it will be set up so that it works right away. And that was just something I wanted to mention. If this video is useful, then please do go over to my channel where I have loads of other maths tutorials, and you can also go over to my website, which I'll link in the description. Okay, so to introduce us to partial fractions, what I'm going to do is actually do a sum of algebraic fractions to start with, and that's going to kind of give us an idea of how this process is going to work. So here I have 1 over x plus 2 plus 1 over x plus 3. And I'm sure this is probably something you've seen before at GCSE. If you haven't, don't worry, it's pretty straightforward. But just to run through the example, well, when we're summing fractions together, the first thing we want to do is make sure they have a common denominator. Okay? And often the way we do that is by just multiplying the two denominators kind of together to tell us what that common denominator is going to be. So if we were to do that, our common denominator would be x plus 2 multiplied by x plus 3. Well, how do I create that denominator on this fraction here? Well, I need to multiply the numerator and the denominator by x plus 3, so let's do that. If I multiply top and bottom by x plus 3, I'm going to get x plus 3 over x plus 2, x plus 3. And if I look at that second term, I want to make the denominator x plus 2 multiplied by x plus 3, and so I'm going to have to multiply numerator and denominator by x plus 2. So let's do that. I'm going to get x plus 2 over, again, x plus 2, x plus 3. Now we have this common denominator, all we need to do is sum the numerators together, and so I'm going to get, well, x plus x, well, that's 2x, and 3 plus 2 is 5. So it's going to be 2x plus 5 on the numerator, and that's going to be over x plus 2, x plus 3, and we're done. Okay, so this would be an example of summing algebraic fractions. Now, sometimes you're going to want to reverse this process, and the method we use to reverse it is called partial fractions. Now, the reason you might want to reverse this process is, say, if you were doing an integration, or you wanted to do a binomial expansion. Sometimes you might want to. There are loads of reasons. The exam might just ask you to split a fraction up into partial fractions. You know, there are loads of reasons you might want to do it, and it's actually pretty straightforward to do. And hopefully this has kind of reminded you of summing algebraic fractions, so it's fresh in your mind for this first example we're going to look at, which is actually reversing what we just did. So we want to write this in partial fractions. So what I'm going to do is bring it down. And so by writing it in partial fractions, it just means splitting it up into, algebraic fractions summed together. So looking at this, hopefully you can see straight away. If I was to say, well, what things would I need to add together to give me this fraction here? You could say, well, one of them is going to have x plus 2 on the denominator. And the other one is probably going to have x plus 3 on the denominator, because when I then add them together and give them a common denominator, I'm going to be multiplying those two things together like we did in the example above. So it's going to be something, which I'll call a, over x plus 2, plus something else over x plus 3. Okay. Now from here, what we do is we say these two things are identical. We use the identity sign. This is an identity. The reason we use this is because we want it to be exactly the same. We want it to be true for all values of x that we can substitute in here. So how do we go about finding the values of a and b? What we're going to do is multiply both sides through by x plus 2, x plus 3. Well, if I multiply the left-hand side through by that, it's just going to leave me with 2x plus 5. If I multiply the right-hand side by this, well, the first term multiplied by x plus 2, x plus 3, let's write it out. It's going to be a multiplied by x plus 2, x plus 3, all over x plus 2. And this second term is going to be b multiplied by x plus 2, x plus 3, all over x plus 3. And you can see these are going to cancel out and these are going to cancel out, and this is going to leave me with 2x plus 5 is exactly the same as a multiplied by x plus 3 plus b multiplied by x plus 2. Now once you've done this a few times, you probably won't need to write out all of these steps in as much detail. You can probably jump straight to this line here, but I suppose it's always good to show all the working that you're doing. Now from here you've got a couple options. Okay, you could expand everything and compare coefficients to solve for a and b. I'm personally not going to show you that method now. I'm going to show you something that I think is a bit better, and that's by doing a substitution. Okay, so we're going to sub in different values of x to help us find a and b. Now we're going to pick these values of x carefully, and you'll see how this is going to work. So the first value of x I'm going to choose is x to equal -3. Now the reason I've picked this number is because if I substitute it in, let's focus on this term here, you can see we're going to get a multiplied by -3 plus 3, which is just a multiplied by 0, and so this term with our a in it, our unknown, is just going to disappear and leave us with an equation solely in terms of b, and that's just going to be able to be solved straight away. So let's do that. So if I substitute x equals -3 into the left hand side, it's going to give me, well, 2 multiplied by -3 is -6, plus 5 is -1. The right hand side, where we just looked at this term here, it's going to go to 0, and we're going to be left with, well, b multiplied by -3 plus 2. Well, -3 plus 2 is just -1, so -1 lots of b. And we want to find out what b is, not what negative b is, so let's divide both sides by -1, and I get b must be 1. So we've now solved to find b. We're now going to do a similar thing again, but to find out what a is. And to do that, I'm going to remove this b here. And so I'm going to make a substitution of x equals -2. So if we now sub it into the left hand side, I'm going to get -2 times 2, which is -4 plus 5, which is 1. And that's going to be exactly the same as, well, a multiplied by -2 plus 3, which is 1, so just 1 lot of a. And remember that second term goes to 0, and so I get a must be 1. Now, the reason we can do this substitution is because we're using an identity here, because it's true for all values of x. It doesn't matter what value of x you sub in, it will always be true, right? So now we have this value of a and b, we can put it back in to what we started with, and that tells me that, well, this turns into 1 over x plus 2 plus 1 over x plus 3, which is actually what we started off with. That was this kind of example question we did at the start. We're done. We've sort of split it up into its partial fractions. Let's look at another example. Now this example might look a bit trickier, but actually it's going to be the exact same process. So the first thing I'm going to do is actually bring this down, just so I've got a bit more space. And I'm going to say, what things would I need to sum together to give me a fraction with these 3 linear terms multiplied together on the denominator? Well, it would have to be something over x plus 2, plus something else over x minus 2, plus some other unknown over x plus 3, right? And these two things I'm going to say are identical. This is an identity. There we go. And then we do the process again. So if you've got 3 linear terms, so by linear terms I just mean things like this, 3 of those multiplied together on your denominator, you're just going to have 3 fractions summed together like this. Okay. From here, we do the same process as before. We're going to multiply both sides through by the denominator here. So that's going to leave me with 13x plus 14. And that's identical to, well, if I multiply this first term here, so this one is the one I'm talking about, by this denominator here, you can see these x plus 2's will cancel out. And that's going to leave me with a multiplied by x minus 2 multiplied by x plus 3. And if you're kind of struggling to see that, feel free to rewrite it out like this here and then actually cancel them out yourselves and see what's going on, right? But I think hopefully you'll be able to see what's going on. Plus b multiplied by, well, the x minus 2's are going to cancel out, and that's going to leave me with x plus 2, x plus 3, and finally it's going to be plus c multiplied by, well, the x plus 3's are going to cancel, so it's going to be x plus 2, x minus 2. And then we do the same process as before, we do substitutions. So the first thing I'm going to do is say, well, let's let x equal 2. That's going to make this bracket here 0, so it's going to get rid of our a. And it's also going to make this bracket here 0, so it's going to remove our C unknown and just leave us to find B. So let's do that. So if I substitute x equals 2 into here, it's going to be 2 lots of 13, which is 26, plus 14, which is 40. So it's going to be 40, and that is exactly the same as, remember, the A term has gone to 0, our C term has gone to 0, and so it's going to be B multiplied by, well, 2 plus 2 is 4, and then 2, let's write it underneath, and 2 plus 3 is 5, so 4 multiplied by 5 is 20, so 20b. Divide both sides by 20, and we get b must be 2. Okay, so pretty straightforward. Let's do the same thing again. This time I'm going to let x equal negative 3. That's going to set this bracket to 0 and this bracket to 0 and allow me to solve to find c. So let's sub it into the left hand side. Negative 3 multiplied by 13 is going to be negative 39. And then we're going to add 14 onto that, so that's going to give us negative 25. And remember, this term here goes to 0 and this term here goes to 0. And so we just need to focus on the final term. So negative 3 plus 2 is negative 1. And we're multiplying that by negative 3 subtract 2, which is negative 5. So it's going to be 5c. Because negative 1 multiplied by negative 5 is positive 5. So we just have to do negative 25 divided by 5, and that tells us that c must be negative 5. Let's now do the final unknown. And so what we're going to do is let x equal negative 2. Because by doing that, this is going to go to 0, this is going to go to 0 and leave us to find a. So let's substitute it into the left hand side first. So we're going to do negative 2 multiplied by 13, that's negative 26, plus 14 gives us negative 12. If we substitute x equals negative 2 on the right into the first term, well, we get negative 4 multiplied by 1, and so we get that this equals negative 4a, and dividing both sides by negative 4, we get positive 3, so a is going to be 3. So expressing this as partial fractions, it's going to be 3, that's our a, over x plus 2, plus b, which is 2, so 2 over x minus 2, plus c, which was negative 5, so I'm going to write negative 5 over x plus 3 like this, and we're done. So you can see it's actually pretty straightforward. I've actually got one final example, which is ever so slightly different, but I just want to emphasize that the process is exactly the same. So rather than having a linear term on the numerator, I've actually got a quadratic term, but that's not a problem. We're going to do the same process. So first thing I'm going to do is split it up into the 3 fractions summed together. So it's going to be this is exactly the same as a over x plus 2 plus b over x plus 1 plus c over x plus 4. Let's multiply both sides through by the denominator, and that's going to give us x squared plus 16x plus 24. What's that going to give us? That's going to give us a multiplied by x plus 1, x plus 4, plus b multiplied by x plus 2, x plus 4, and finally plus c multiplied by x plus 2, x plus 1. And now we do our substitutions exactly the same way as before. So first I'm going to substitute x equals negative 1 to create this to be a 0 and to make this to be a 0 as well. So let's look at what that's going to give us. It's negative 1 squared, which is 1, plus 16 times negative 1, which is negative 16 plus 24. So that's going to turn into 9. On the right hand side, well, this term we just said goes to 0. The middle term, that's going to be negative 1 plus 2, which is 1, and negative 1 plus 4, which is 3. So that's going to be 3b. Dividing both sides by 3 gives us b is 3. So that's pretty straightforward. Let's find the next term. So I'm going to make a substitution of x equaling negative 4, because this is now going to go to 0, as is this, and that's going to allow me to find my c. So let's sub it in. Negative 4 all squared is 16, plus 16 times negative 4. That's going to give us negative 64 plus 24. And that's going to turn into negative 24. And that's exactly the same as, well, negative 4 plus 2 is negative 2. And negative 4 plus 1 is negative 3. Multiplying these two together gives us plus 6c. And dividing both sides by 6 gives us 4, or negative 4, sorry, so c is negative 4. Finally, let's do our last substitution. Let me just clear off this working out. So we're going to make a substitution of x equaling -2, because that's going to turn this term equal to 0 and this term equal to 0. So subbing it in on the left hand side first, we're going to get 4 minus 32 plus 24, and that's going to give us -4, and that's exactly the same as, well, -2 plus 1 is -1, and -2 plus 4 is 2, so -2a. Dividing both sides by -2 gives us 2 must be a, and so we've converted this into partial fractions, where we're going to have 2 over x plus 2 plus 3 over x plus 1 minus 4 over x plus 4, and we're done. Okay, so it doesn't matter if there's a quadratic on the numerator, but to calculate partial fractions, the only kind of requirement you need is that the degree of the numerator is less than the degree of the denominator, like I mentioned at the start. In this case it was as well, so it's fine. Okay, so hopefully this video was useful. If it was, please do go over to my channel where I have loads of other maths tutorials, and you can also go over to my website, which I'll link in the video description. If you go over there, it's a bit easier to navigate through all the different videos I've made. Thanks for watching.